Okay, the next thing we're going to work through is performing ratings. So let's dive deeper into that. And I already covered justifications, by the way, a little bit when going over our taxonomy, and it's in the instructions document. So I won't dig into justifications here, but they're quite important. But let's talk about ratings. So simply, we're just marking which items the response checks off. This is the simplest part of the task. I mean, you literally just click a button and write a sentence or two about what you saw. But it needs the closest attention to detail. Like if you say something has no issues and it has issues, that's like a pretty obvious error. And if you say something has issues and it doesn't have any, well, that's an error as well. So you need to be super careful when making these ratings. So I want to talk about specifically your two roles when rating. You're going to be two things. First is going to be a math checker. So the first part is, are you checking the math? So the first thing is, did the model provide the correct final answer? You want to test whether the model provided the correct final answer. So remember, we want prompts that have one correct solution, a final answer, they're solvable. And after you wrote your prompt, you wrote the final answer that you thought should be. So double check quickly if it provided the correct final answer. After that, did it write out incorrect steps or make incorrect reasoning steps? So you want to basically be a mathematician. Imagine you're a teacher and the model response is your student. You're basically going through and identifying areas where it falls short or makes mistakes, and then basically go from there. The next part is going to be proofreading. So you are a language expert. So check for unnatural language, awkward phrasing, grammar errors, and basically make sure that it's speaking your language and localization with high quality. So, for example, if it's making a response in Arabic, but it's actually like replying in super formal Arabic, not casual. If you ask them something in Egyptian Arabic, well, that's going to be like unnatural language, and you want to make sure that it's referring to things by the correct context. Did it follow the instructions? So did it actually answer your prompt and stay within the constraints? And lastly, is the information accurate? So it gets facts wrong, so make sure that everything is true and correct. So basically, you want to check the math super vigorously, and you want to be a proofreader. You are a language expert and a mathematician, and that's going to be your job. So, one, you're a math teacher checking a student's response, and two, you're a language teacher checking a student's response and grading on both. Let's talk about how to grade some of the bigger dimensions here. All dimensions are equally important, but these ones tend to be the trickier ones. So instruction following. So this is going to be in your instructions document as well. It's a step-by-step guide on how to evaluate instruction following. And basically you want to review the instructions provided, step one. Step two, compare the response to the instructions and understand, did it ignore any parts? Did it misunderstand it? Three, if you wrote constraints like a word count or a structure, maybe you said, hey, respond with only the number, or maybe you say, hey, like it's a word problem. I have $100. My friend takes $16. I have $5. Answer with the units. So it should say, for example, cents. That's a type of constraint. And determine the clarity of adherence. So were there any unnecessary additions or misinterpretations? And basically, that's what we're looking at. Let's look at an example. That's probably the most helpful. So let's say we look at a prompt, and the prompt is, what is the slope of the line between 2 and -1 and 4, 2? And the response goes, using the point 2 and -1, and it goes and calculates that the y-intercept is 4, -4 specifically. Well, then here we're seeing, let's go through each step. What is the instruction we provided? Well, we were very clear. We gave it the information. It's solvable. When we said, what is the slope of the line? And I compare what it answered, and it answered the y-intercept. So clearly here, it misunderstood my prompt, and this has issues because it did not understand my prompt. So this is an instruction following issue. Okay, let's do another example. Calculate the slope of the line between 2 -1 and 4, 2. Present this in y equals mx plus b form. So the model here has to do two things. Let's go through the step-by-step guide. Step one, when we review the instructions we provided, it has to do two things. One, calculate the slope of the line. So it has to calculate it and find what the slope is. And then two, write it in y equals mx plus b form. So it might even have to solve for the b-intercept or the y-intercept here. Let's look at the model response. So the response calculates the slope. So it goes through y minus 1 minus y1 over x2 minus x1, calculates the slope correctly, but it didn't present it in y equals mx plus b form. So while it understood the prompt, it ignored step 3, the constraint, so how it should present its answer, and therefore it failed here as well. So this has instruction following issues. And so by following the step-by-step guide, you're able to find instruction following, or IF, I being instruction, F being following, errors super easily. Let's go through truthfulness. And so here's an important distinction I'm going to make. Instruction following is that the model understand your prompt and adhere to it. Truthfulness is, did it solve it correctly, like truthfully, and did it lie? So if the model calculated the slope and presented it in y equals mx plus b form, but it made an incorrect calculation, that's a truthfulness issue because it made a mistake, like it made a truthfulness mistake. So this is something that's going to be really important. Math errors are more often than not actually truthfulness issues. An instruction following issue is if it, 1, ignored your prompt, or 2, ignored your constraint or misunderstood it. If it understood it, but it answered it incorrectly because it made a math error, that's truthfulness. So let's go through some examples. To do truthfulness ratings, you have 5 steps. Step 1, identify all math steps and claims. So literally go through the response and highlight where you see mathematically relevant claims or something that could be wrong. Next, verify the math and reasoning. So the model almost always makes a sneaky math or reasoning error. So you want to cross-check reasonable sources. If you need to double-check something, use Wolfram Alpha, a calculator, or Google. Every claim has to be true, and if it's not, then you mark that as an issue and explain why. If it uses a theory or a property, you want to make sure you use it correctly, and then you want to double-check everything. So let's go through an example real quick. Let's say we're going to go through truthfulness. So again, calculating the slope of the line between 2 minus 1 and 4, 2, and we see how it calculates it, and so we see that it says the slope is 1 over 2. What you do, according to our step-by-step guide, is go through each line, identify the claims, and verify each one. And if you do that here, you're going to actually see that it made a mistake at step 2 when you're verifying the math and reasoning. Because it said that 2 minus negative 1, which is in the second line, is 1 over 2, right? Like it said 2 minus negative 1 equals 1. You can see that right in the second and third line of the calculations. So this had a truthfulness issue. The prompt here understood what it was trying to solve, but it solved it incorrectly. It made a truthfulness issue, and so we identified the claims, we verified the math and reasoning, and we found this had issues because it made an error when calculating 2 minus negative 1. Let's go through another example. Let's say that we ask it to calculate the slope of the line between 2 minus 1 and 4, 2, and I know that this is going to be 3 over 2. So what I do here is, let's say I know that the final answer is 3 over 2. I look at the model response, I double check, okay, the slope of the line, it used 2 minus 1, it used 4, 2, and then I go, okay, cool, this looks correct because it said the final answer is 3 over 2, and I mark this as no issues. I have just performed a low quality task if I did that. Do you know why? Well, take a look at it again, right? Because I didn't follow the step-by-step guide of identifying each step and verifying each step, and instead I just went, oh, I know the final answer is 3 over 2, and then I read the last line, see 3 over 2, and quickly skim the other sections. If I did that, I missed an error, which is that it dropped the negative sign. So notice the coordinate in our prompt of 2 minus 1 has a negative 1. So when we calculate the slope, it should be 2 minus negative 1 instead of 2 minus positive 1. Well, the model makes this error frequently, actually, where it forgets the negative sign, but then kind of corrects it. So it makes 2 mistakes, and it corrects itself, but it doesn't actually write it correctly. It makes that mistake a lot. So if you only look at the final answer and not each step super carefully, you'll actually miss issues like this. So here, because I didn't follow the step-by-step guide of going line by line, evaluating each claim independently, and then making a decision if it has issues, well, I made a mistake because I just skipped to looking at the final answer. So basically, the lesson here is when you're rating truthfulness and math claims, you want to go line by line and check every single thing. Because even if it might look right, there may be a mistake, and so you want to double check. Actually, let's go through one more example. A triangle has sides of length 7 centimeter, 23 centimeter, and 24 centimeters. What is the height of the triangle corresponding to the side length 24 centimeters? So the response uses Pythagorean theorem. It takes the hypotenuse and the base side, and it basically calculates what h is going to be. And so if I go to step 1, identify all the claims. Step 2, verify the math and reasoning. Step 3, evaluate the correct application. Step 4, identify errors. Step 5, double check. I'll notice 2 things. So I'm going to take a pause here. You can pause the video. What are the 2 errors? Okay. Let's go over the 2 errors. Error number 1. Well, you actually can't use Pythagorean theorem to calculate the height, right? That doesn't make any sense. Pythagorean theorem is to calculate, we have the 3 side lengths. To calculate the height, we're actually going to need to use the area formula. So this is actually incorrect. Second, though, we have a bigger problem is, even if we could use Pythagorean theorem, the triangle isn't a right triangle. So remember step 3, evaluate the correct application. If you look at the side length, 7, 23, and 24, they don't form a right triangle. And we can't use the Pythagorean theorem on a non-right triangle. So many times the model might make a mistake because it'll use a property or it'll use a formula, but it actually can't use the formula in the context of the information that you provided, because maybe it's not a right triangle, maybe it uses the area of a slope, but you actually provided a quadratic equation. So you always want to make sure that it's correctly applying the information you're giving it. Lastly, fluency. So remember, we talked about you being a language expert. So basically the step-by-step here is identify the required style, the tone, evaluate awkward phrasing, any spelling mistakes, assess clarity and flow. And like I mentioned, you're the language expert. The AI might not speak your language perfectly, so look out for things that sound odd. Make sure it's respectful of control context and that it's localized and relevant to your language and locale, and that it doesn't